You've been playing Doom since you were like 8 years old. You know how it feels. You pull the trigger, the demon dies. Feels amazing, right? But there's something that nobody ever actually asks. How does the game know that it hit? Like, there is no bullet, there is no projectile flying through the air, none of that. The second you pull the trigger, the game has already decided whether you hit or not. It's instant. And the way the PlayStation 1 version pulls this off is genuinely one of the most elegant pieces of 90s engineering I have ever dug through. So today we're cracking open the P-shoot and the P-enemy file in the PSX Doom source, and I'm going to show you exactly, step by step, what happens from the moment you fire a weapon to the moment a demon takes damage. So let's get into it. Before we dive in, real quick context for anyone new here, I do these technical deep dives into PlayStation 1 and PlayStation 2 era game code. These games, they were built with insane hardware constraints, like 33 megahertz processor, no GPU acceleration for geometry, and ID Software still shipped one of the most satisfying shooters ever made. And that doesn't happen by accident. There are two main files that we're going to be working with today. So pshoot.c handles all the low-level math tracing of a shot through the world. And the penemy.c file is where the monster AI decides when and how to actually use that system. They work together like a decision maker sitting on top of a very precise engine. And the key concept tying all of this together, the thing that makes Doom's combat feel the way that it does, is something called a hit scan trace. Alright, so here's the core idea. When you fire a pistol, a shotgun, a chain gun, heck, even when monsters fire at you, the game doesn't spawn a physical bullet object. There is actually no projectiles. So instead, the game casts what's called a hit scan trace. Think of it like a laser pointer. The moment that you press fire, there's an invisible line that shoots from the character's position to the direction that you're aiming. So it's instantaneous. Done. Whatever that line hits that's what's going to take the damage. The way that this is set up in the code, the attack routine first builds what's called a div line. That's literally just the 2D line segment from your position extending out to your aim angle. And here's where it gets really interesting. It also defines vertical aiming windows. See, Doom's world is technically 2D. The maps are flat polygons, the floors and ceilings are defined by height values, not actually 3D geometry. So the engine has to fake vertical aiming using slopes. Your vertical window is defined by a top slope and a bottom slope, calculated from your eye height to where you're looking. So if a target falls within that vertical window and the 2D line passes through it, it's a hit. And this is why you can shoot a demon standing on a ledge above you and actually hit the bottom of his feet. Or miss entirely because the ceiling is in the way. The math cares about vertical space, which, for games that look flat, is pretty mind-blowing. Now we have our trace, our invisible laser. The next problem is, how does the game figure out what trace hits without checking literally every single thing in the level? On a PlayStation 1 with limited processing power, brute forcing that search would tank your frame rate instantly. The answer is the BSP tree, binary space partitioning. And this is genuinely one of the coolest data structures in all of game development. So here's how it works. When the map was built, not when you're playing, but when ID Software shipped the game, the level geometry was pre-organized into a binary tree. Every node in that tree splits the world into a partition line where the hit scan trace fires. The engine just walks this tree at each node and asks, which side of this partition does my trace come from? It only visits the other side if the trace actually crosses the line. This means the engine finds the nearest hit first, right? So every time, very fast. No wasted checks. The first valid intercept of the BSP finds is guaranteed to be the closest one to the shooter. When it reaches the bottom of the tree, that's what's called the subsector. It checks all the line segments and objects inside that subsector against the trace. And here's the two-sided line logic and where Doom's world really comes alive. A one solid line, a solid wall, immediately blocks the trace. Done. But a two-sided line, a doorway, a window, an opening, the game calculates the open space between sectors and converts that into slopes. Then it asks, does the shot vertical's window fit through this opening? If yes, the trace keeps going. If not, the wall blocks it. This is exactly why shooting through windows feels right in Doom. The engine is literally doing all the geometry homework on every shot. Hitting monsters, because monsters aren't lines, right? They're objects. The code literally calls them things. And hitting a thing involves a two-step test. Step 1. Each monster is approximated by a box. A diagonal line across its collision radius, fast and a cheap 2D test. If the trace might pass through it, then step 2 kicks in. Step 2, the engine calculates the monster's top and bottom slope, the same vertical slope system as before, and checks if that overlaps with the aim window. If it does, that monster is your hit. The game records it as a shoot mob J and calculates the exact impact point and spawns the appropriate visual effect. Blood sprite for flesh and spark puff for walls. Here's the thing that took my brain a second to wrap my head around. The shoot slope that gets calculated is the midpoint of the overlap between your aim window and the monster's vertical span. So it's finding the most probable vertical hit automatically. That's the level of position baked into this 1994 engine. And all of this pshoot.c is the raw engine and the AI is the p enemy. It doesn't redo any of this math. Instead, it acts as a decision layer on top. It decides when to attack, which type of attack to use, and then calls these primitives. So there is p-line attack. Fires a hit scan trace in a direction. So this is like the pistol, the chain gun, the shotgun, all of these types of shooting weapons that we're using. We've got the p-aim line attack. This computes a vertical slope directly toward the target first and then fires. This is how monsters aim accurately at you even if you're at a different height. This one's different. The spawn missile is actually a physical projectile object, the fireball and the rocket. That has its own movement and collision system entirely separate from the hit scan tree. That's why you can dodge a fireball, but you can't dodge a hit scan shot. This was already decided before the animation even plays. Okay, so why does any of this matter? Why does digging through a 3D 30-year-old C code tell us anything interesting? Because it explains why Doom is still satisfying and successful to this day. The shotgun's iconic spread, that's not some fancy spray pattern system. The code just fires multiple hit scan traces per shot. So each at a slightly different angle. Multiple indent laser pointers, right? So they're going everywhere. If 2 traces hit different enemies, you hit 2 enemies. It's elegant. The way that shots interact with vertical geometry, like shooting over a ledge or a blast that clips a monster's feet because of the floor height difference, that's the slope comparison system, working exactly as designed. And the contrast between hit scan weapons and missile weapons, that's an intentional design enforced by the code split. Hit scan attacks are about raw aiming. You either aimed right or you didn't. Missiles are about space and timing. They travel through the world and you can react to them. The imps throwing fireballs at you, that's the P-spawn missile. You can dodge that. The chain gunner running right up to you and lighting you up the second he sees you, that's the P-aim line attack followed by line attack. There is no travel time. That difference in feel between enemy types isn't accidental. It's the code expressing intentional game design. And the fact that all of this runs efficiently, correctly, and on a 33 megahertz PlayStation 1 processor in 1994, the BSP tree doing all the geometry checks, slope math, intercept, ordering, AI decision trees, all inside a single game tick. That's not just good code. That's a work of art. All right, well, that's the full breakdown of how attacks work in the PS1 Doom. The moment you pull the trigger all the way to the demon taking damage. We covered hit scan traces, BSP traversal, two-sided line logic, mob intersection, and the AI decision layer sitting on top of all of it. It's this kind of under-the-hood breakdown is your thing. Honestly, there's so much more hiding in the code base. The movement system, the sound propagation engine, the lighting, the way that it was faked on the PlayStation 1. Every single one of these systems has a story just like this one. And it's not just Doom either, it's every game. So if you want to see me dig into those next, hit subscribe and drop a comment letting me know which system you want broken down first, or if there's a different game you want to see broken down. I read all the comments because I'm very interested in showing you guys what you want to see. So, I'll see you in the next one, and until then, I hope you have a good one.